Hey guys, my name is David Roach. I look after Terrain-Tronics, and this is a quick intro to the Harlech LED controller. So what is a Harlech? Well, it's a little controller board that's designed to help you make terrain like this. So terrain that can have flashing lights in it with specific patterns and so on. This is just a runway or an airstrip that I created, but it could be anything. It could be a piece of D&D terrain. It could be something for Warhammer, Age of Sigmar, or 40K in this case, Kill Team, anything. Um, the board itself is a daughter card that sits on a conventional board that you can get from Amazon and so on. So you can control 8 LEDs in the patterns that you can program into the device. So you program them in to flash in a specific sequence and for how long and how bright and so on. And every time you switch the board on, it'll just start following that. You have a global control over the brightness using a screwdriver. That's pretty useful. So you build up your terrain and then you decide, whoa, that's a little bit too bright. Let's back everything off together. That's pretty useful. You have individual control of brightness in your pattern design. So, if you want it to flicker in a certain way, or you want, this one on for longer than others and so on, you can do that in your pattern design. It's, as I said, it's a daughter board for a standard off-the-shelf Wi-Fi chip that you can get from Amazon. And it's based on this WeMOS D1 Mini. So the WeMOS D1 Mini is the circuit board here, and on that little circuit board is this module, which is based on ESP8266. Now that's electronics terms for essentially a Wi-Fi chip that's Arduino code compatible. Now the Arduino bit's important because it means it's easy to program on anyone's PC. You download the software for it, you can copy code examples, and just chop and change it together. And one of the nice things is it's easy to power from USB. You see a USB micro here, and it's small as well. It's not like these big circuit boards like a Raspberry Pi or something like that. It's open source, so I'll be sharing all the code and all the schematics and so on. If someone wants to copy it, they're welcome to do so. It'd be nice if they just bought them from me, but at the end of the day, I want things to be better for the entire community. And it's expandable. So the nice thing about this, right now in the software, I'm not using any of the Wi-Fi capability, but with a few extensions to the software, suddenly this becomes a Wi-Fi controlled system. So for example, one of the people I was speaking to said, hey, in D&D, when we get into battle, could I switch all the lights to be red? Well, yes, you could have one of these for your red lights, and you hit a button, on your PC in a web browser, and suddenly, your whole area turns red and so on. So some really cool ideas that you can do with lighting. It's really, really easy to hook up. So you're gonna, plug it onto an existing board. This top controller here allows you to control just anything in the software. You read that value essentially in the software. This one down here sets the maximum brightness, really easy. And then these connectors here, these 16 pins here, you connect to your LEDs. There's no need for any resistors. You hook them all up directly, and they should shine bright. Now, in this case, a lot of people think, oh, I got to get a soldering iron and all this kind of thing. I didn't use a soldering iron, even though I have all of that equipment. What I used was wire wrap. Wire wrap is very, very thin wires with a special tool that you can get from Amazon, where you wrap the wire around the thing you want to make contact with, and it's a really, really strong connection. In fact, the Apollo missions, NASA built those computers using wire wrap technology because they believed it to be stronger than a soldering iron connection. So very, very easy to do, child friendly because you're not going to burn yourself, you're not going to electrocute yourself. Very, very easy to get into. So let me give you a quick example, of walkthrough of how I built the airstrip here. So I planned, and I said, okay, just like a traditional piece of terrain that many of you have done before, what I had was some chipboard here and some foam board from Dollar Tree, where you just pull the paper off the front of it and so on. And that's pretty important because I can cut into that foam board and make routes for the wires to go. So I'm planning where the LEDs can go. I'm allowing for the routing of wires and so on. And then I started laying it out. Now I went a little bit extreme here and I made all these channels for the wires. I really didn't need to do that. But the key things here is, I'm putting down exactly where my little fixtures are going to go. First, I designed this fixture. You don't have to. You could just use a piece of foam with a hole cut in it to put the LED. But you can see here, I've got two of them here and I put more in as we went along. I've got channels for the wiring to go through. And I used very, very thin wire. So this wire comes from Amazon. It's $10 for a reel of 1,000 feet. And so it's very, very thin because we're not transferring a lot of power here, and so it's very easy to route through. In fact, you can see here I sliced the foam and pressed the wire into it, and it held just fine. I didn't need these big channels, but your mileage may vary. So then I connected stuff together. I used wire wrap, as he said. So in wire wrap, over here, you strip the wire a little bit, and then you insert the wire into the tip and wrap it around the leg of the component. And then at the other end, I used 0.1 inch headers, standard headers you can buy off Amazon. Again, there'll be a link available that you literally just crimp. You crimp the wires into it, and it just works. Very easy, no soldering, no danger. Very easy for families to use together. I tested the wiring just by using a simple pattern. You can see here, that lets me know that all the LEDs are working. And then I carried on with the assembly and painting. And so, I put sandpaper on top because it's a road, and the sandpaper is classically what we use to represent road. I sprayed it all black, a bit of brown on the sides, for the mud on the side, and for the muddy banks, I put some tape down. I sponged grey and white lines, and voila, done. And so that's the board finished. Um, the other question that comes up is how much battery does it use? Well, that depends on the number of lights and the number of patterns run. The one that you saw pulls about 40 milliamps. That's about 5 for every light and the chip itself and everything. So a 10,000 milliamp hour battery lasts about 250 hours or so. It's been on for 3 days so far and it's still going. No problem at all. A much smaller USB power pack could be used, and I have plans as part of Terrain-Tronics to release that kind of thing. But an off-the-shelf battery pack will work just fine, and you could easily modify the code. Just after 4 hours, it switches off or something just to save you power. So where do you find out more? Well, I'm on the usual social networks. I've just set a lot of these up. I have GitHub for code, schematics, and layout. A Tindy store will be available very soon, and an Amazon shopping list for any extras, so the WeMOS boards, wire, essential tools, and so on. But if you do have any questions in the meantime, please go ahead and send me a message through the usual social networks, or you can email me at terrain@terraintronics.com. All right, thanks again, folks.